Good morning, all of you. Today we discuss about that internal rate of return. So, to uh, give a evaluation of a project, evaluation of that project, we have different methods. In that project evaluation method, one of the method is the internal rate of return. So, in last video we discussed start to discussing about that internal rate of return. So, internal rate of return, we can say that it is a interest rate. It is interest rate at which that cash inflow at which cash inflow is equal to cash outflow. Cash inflow is equal to cash outflow. So we can say that at particular interest rate, whatever that cash inflow at particular interest rate, that we can equate to the cash outflow at particular interest rate. Cash outflow at particular interest rate, and at that situation we can say that that particular interest rate is a internal rate of return. That particular interest rate is a internal rate of return. So internal rate of return is also considered as a break even interest rate. So at that break even interest rate, all the we can equate that cash flow and the cash outflow and cash inflow. So at that particular interest rate, that cash outflow and cash inflow are the equal, at that equal. So in last video we discussed about that. We write this equation like this. We write this equation like this as a cash inflow and cash outflow. Cash inflow and cash outflow. We equate this cash inflow and cash outflow, and now uh, we move further. So here we go through one first numerical. We go through first numerical in last video. So in this cash, in this interest rate of return, we have to find out. That particular interest rate, at the particular interest rate at which this cash outflow and cash inflow are equal. At which this cash outflow and inflow are equal. So here this I dash is nothing but the internal rate of return. I dash is nothing but the internal rate of return. And when this internal rate of return is greater than minimum attractive rate of return MARR, then we can say that investment is desirable in that particular project. Investment is desirable in that particular project. If it is less than MARR, then we can say that investment is not desirable in that particular project. Not desirable in that particular project. So we can judge that particular project by considering this internal rate of return. Now this internal rate of return, how you can calculate this internal rate of return? Now this we can equate this cash outflow and cash inflow, but we can use any method that we studied in the last videos as a present worth method, annual worth method. So such methods, present worth, annual worth, or future worth method. So such methods we can utilize to equating this cash outflow or cash inflow. You can use any method out of these three methods, and you can equate this cash inflow, cash outflow. So here in this, here we used that particular present worth method. We use present worth method. Now, how you can calculate that particular internal rate of return? So to calculating that internal rate of return, we put or we assume two rates. We assume two interest rate and find out that particular present worth. Find out that particular present worth at particular interest rate. Suppose we assume two interest rate, 10% and 12%. So we find out that particular present worth at 10% and particular present worth at 12%. So here it is a desirable that uh, uh, that value of present worth by considering this interest rate are have some difference. So one should be minimum and other should be maximum. Other should be maximum. And then we can we can find out that interest rate I at which this present worth is equal to 0 by interpolation formula. Now, what is this interpolation formula? So here this interpolation formula is given. So here, here in this particular example, in this last example, so this we equate this cash outflow and cash inflow. In another word, we can say that if you take a difference between this cash outflow and cash inflow, that becomes a zero. When particular interest rate of return I, internal rate of return I. When we equate this, we can shift this right hand side toward the left hand side, and that right hand side now becomes a zero. It means that we consider here to calculate interest rate of return present worth method. So in another word, we can say that when present worth is equal to 0, then we can say that at that particular internal rate of return, when present worth is equal to 0, then that interest rate is nothing but a internal rate of return. That interest rate, when present worth becomes 0, that interest rate is nothing but a internal rate of return. now here, and that is denoted, or that is written here, like this. That is written here. If I dash is again I dash is greater than or equal to MARR, that alternative is acceptable. That is written here. So how you can calculate that I dash? I dash here represented as a internal rate of return. How you calculate that I dash? So here here in last numerical, here one example is given. We discussed this example in last video. Just hurriedly we go through this example, and then we move toward the next examples. So in this example, we find out that present worth. We find out this present worth at 10% and present worth at 12%. And that value for 10%, that present worth value comes as a 43,598, and for 12% this value comes as a 12,056, 1,25,672 rupees. So we get here two values. So we get here two values. Here we get two values. This is the present worth value on y-axis. This is the interest rate value I on x-axis. On the x-axis. Now we have two interest rate, 10% and 12%, and we have two present worth value, 1,25,000 and 43,598, and some intermediate value. At some intermediate value of I, this present worth becomes as a 0. At intermediate value I, this present worth becomes as a 0, and that particular interest rate I is nothing but a internal rate of return. IRR. IRR. So we have to find out this internal rate of return intermediate value. So we have maximum value, we have minimum value, and some intermediate value we have to find out. And that value at which this present worth becomes a 0. So how you can calculate this? So we can calculate this like this. So this maximum value 1,25,672. So we find out this like this. Maximum value as a 1,25,672 minus maximum present worth minus minimum present worth 5,000 98 divided by difference between this maximum and the minimum interest rate. Difference between maximum and minimum interest rate. So this equal to this term equal to now intermediate value I. For this intermediate value I, we have to find out intermediate value. So this at this I value, this present worth becomes a 0. So 43,598 minus present worth now 0, and difference between these two interest rate is a I minus 12. Difference between two interest rate is I minus 12. So after simplifying this, we get some I value. After simplifying this, we get some I value. That becomes as a 13.062. That becomes as a 13.062, which is less than minimum attractive rate of return 20%, which is given. So we can say that this investment is not desirable. We can say that investment in this project is not desirable. So we can find out by interpolation formula. That intermediate interest rate. Now here two values of this present worth. Are maximum are different. Two values of this present worth is different. One is minimum, another is maximum. And we draw and we consider this range. We consider this range is a short one. This range is a short one. You can also consider 10% and 15%. But it is always better to take a shortest difference. So that this accuracy is become higher side. On the higher side. So here we assume that linear variation. In between this present worth. And it is also a straight line. For a small interval of the interest rate. If this interval become higher, then this that accuracy reduces. Range between this of this interest rate is higher, then this accuracy becomes reduces. So it is always desirable to take a small interval of the interest rate. So we go through the next example. So in this that investment in this now in this example, that investment of rupees 1 lakh is required in an existing workshop whose annual revenue is expected of rupees 40,000 for next 5 years. Out of this revenue, 5,000 is spent annually on the maintenance of that workshop machine. So this is there is a no salvage value of additional equipment installed after 5 years. So the management is willing to increase investment if the minimum rate of return is 15%. Using IRR determine whether the investment is desirable or not. So here we have this present worth formula. like this. Present worth is equal to this formula. We have this present worth formula is equal to minus P present worth is equal to minus P plus annual revenue into this factor. This factor represent compound series present worth. This factor represent compound series present worth. PF factor represent the single payment present worth. This PA is considered as a uniform series present worth, and PF is considered as a single payment present worth. So these are the considered as for compound interest. These are considered for the compound interest I. These are considered for the compound interest I. So uniform series payment worth. So this PA is calculated annually. This PA it means at particular rate, at particular interval of time. At particular interval of time, we find out we find out that particular interest rate. Here this PA, it means this PA represent a factor. This PA represent a factor. So when we consider this PA, when we find out interest rate, we find out interest rate at particular interval of time. Suppose after 1 year, so there is a total 5 year period of time, so in which that 5 year period of time is divided into 1 year into 5, divided into 5 slots. So at each year, what will be the interest? At each year, what will be the interest? Then how you can calculate that interest at each year? Then you can consider this P by A factor. So it is a uniform series present worth. Uniform series present worth. When P by F, we represent P by F, then it is a represent for the single payment present worth. It is represented as a single payment present worth. So it represents the interest rate when for a particular period of time, for a particular period of time. And PA is interest rate for the for a particular slot. Suppose that 5 year divided into 5 slots. So at 5 slots means 5 years. Five slot means 5 years. So at each year, how much is that interest? So we consider that P by A factor. We consider this P by A factor. How you calculate this P by A and P by A factors? That will be that formula we already discussed. Tabulated. This formula are tabulated in this previous videos. And that we discuss or that we go through. This is the uniform series payment worth. This formula P by 1 plus I raised to n minus 1 divided by I into 1 plus I raised to n. So n is a number of period of time, I is the interest. P by single payment present worth. So it is that factor we can calculate as a 1 upon 1 plus I raised to n. 1 upon 1 plus I raised to n. So I is the interest rate, n is the particular period of time. So with this formula, we find out this factor. And then we find out these values. So here, now we are discussing this example. In last video. We go through this example. In last video, we go through first numerical. This is the second numerical. This is the second numerical. So here what are the given conditions? What are the given values? Are the investment P is given as a 1 lakh. Investment P is given as a 1 lakh. Annual salvage value 0. There is no salvage value. And period of time is n is equal to 5 years. Annual revenue is a 40,000. Per year. Annual cost or annual expenses is equal to 5,000. Minimum attractive rate of return is 15%. And present worth becomes now here. Present worth becomes as a 0. Is equal to, we have this formula. Present worth formula that we again discussed. So here this present worth formula is a minus P plus annual revenue into this factor, uniform series present worth P by A factor with the interest rate I 20% minus annual expenses into this uniform series present worth for factor for a period of time 5 years. Now how you can solve this? Now we have to find out at particular interest rate this p by p present worth becomes 0. This present worth becomes 0 at particular interest rate I. So to find out this, we consider two interest rate value. We consider two interest rate values, 10% and 12%. You consider two interest rate values, 10% and 12%. We can consider also 10% and 15%. It is always desirable to take a difference between this interest rate is a smaller one. Difference between interest rate is a smaller one. So find out this present worth. Put I is equal to 10% and 12% into this formula of present worth and find out these values. Find out this present worth values as a 26,000 168 and 32,783. Now again using this interpolation formula, using this interpolation formula using here write like this: difference between this present worth divided by difference between this interest rate is equal to difference between now intermediate value and present worth and divided by interest rate of that particular present worth. So this is a interpolation formula. Now after simplifying this, we will observe that I value that we calculated by this interpolation formula, comes as a 19.91. So it is greater than minimum attractive rate of return. So we can say that this investment is desirable. Now we move toward the next example. So in the previous example, we can observe that interest rate comes as a greater than the minimum attractive rate of return. So in that case, we can say that investment for that particular project is a desirable one. If it is less than, in first example, that interest rate becomes as a less than minimum attractive rate of return. So in that case, we can say that investment in that project is not desirable. So now we move toward the third example. So these examples are simple. So in present worth formula, you just put values. By considering two interest rate, because interest rate is unknown to us. So we consider two interest rate. Suppose 10%, 12%. Find out present worth value for that particular interest rate, and then we have two values of present worth at two interest rate. Then we have to find out interest rate at which this present worth value becomes as 0 by interpolation formula. And then we say that particular interest rate present worth is a 0. Now we move toward the third example. So this, in this example, this Manish has planned to make a deposit of rupees 12,000 every year for next 5 years. The first deposit, that is a deposit for year 1, is made at the end of year. The Manish anticipates that he will need to make continuous withdrawal. Of rupees 8,000 from 1 year after the last deposit for the next 15 years. Calculate to the nearest percent the effective annual internal rate of return Manish is earning on his investment. Now in this numerical, this Manish is investing for the 5 years. Manish is investing for the 5 years. Manish is investing for 5 years. So first year he invests some value 12,000. For second year he invests some value 12,000. For third year he invests some value 12,000. some fourth year he invest some value, 5 years some invest some value. So at this each year he invest 12,000. He invest 12,000. Now after this investment, so he also withdraw rupees 8,000 from 1 year after the last deposit for next 15 years. Also deposit for next 15 years. So he also withdraw some amount. He also withdraw some amount for the 15 years. Now add this. He deposit 12,000 each year. Also he withdraw some amount 8,000 after each year. 8,000 after each year. So he deposit 12,000 each year, also withdraw 8,000 each year, and this will continue up to the 15 years. This will continue up to 15 years. This will continue for the 15 years. So 12,000 he invested for the 5 years. 12,000 investment is only for 5 years. And total withdrawal is considered for the 15 years. Withdrawal is considered for 15 years. Investment is considered for the 5 years. And in this 5-year investment period, there is a 8,000 also. 8,000 is also deducted in this 5 year. 8,000 is also deducted in this 5 year. So 12,000 invested for 5 years. 12,000 invested for 5 years, and 8,000 is also deducted. This 8,000 deducted for in this 5 year also, and remaining 10 years also he deduct 8,000. Remaining 10 years he also deduct 8,000. So with this given condition, we have to find out interest rate. At which he will get income. Now to find out internal rate of return, cash outflow and cash inflow are the equal. So cash outflow here consider as a like this. Here cash outflow we consider as a like this. 8,000 for the 8,000 deducted for 15 years. 8,000 deducted for 15 years. Also 8,000 deducted each year. 8,000 deducted for each year. Here P by a factor. It is a uniform series present worth. So it is deducted at each year. And this P by F, it is a single payment present worth factor. So this is a considered for the 5 years. For 5 years, from this 12,000 invested per year, and 8,000 is deducted for the each year, and this situation is a for 5 years. First 5 years this situation is a consider. For first 5 years this situation is consider. 12,000 invested and 8,000 removed for first 5 years. And after that only 8,000 is a investment is a stop, and 8,000 is a removed after each year. So for first 5 year 12,000 is a invested, and also 8,000 is deducted. So this for this deduction for 5 years, this factor will be considered. For deduction for the first 5 years of 8,000, this factor is considered. P by F with percentage with some high percentage, and for the 5 years. And what are the cash inflow? What is the cash inflow? So the cash inflow is nothing but this 12,000 investment for the 5 years. For 12,000 investment for 5 years, and that investment is done yearly. So this P by A considered for the yearly investment. P by A considered for the yearly investment. So with this equation, with this equation we move further. With this equation we move further. So we understand here 12,000 investment for 5 years, 12,000 investment for 5 years, and that particular cash inflow we calculated at particular interest rate I, and that interest rate I is not known to us, that not known to us. And cash outflow is nothing but 8,000 we deducted for 15 years, and these are deducted for 15 years annually. At end of the each year 8,000 is removed, and this p by f factor is considered for the for the for first 5 year 8,000 is deducted. For first 5 years this 8,000 is deducted, and also 8,000 deducted, also that investment is also done for that particular first 5 years. Investment is also done for the particular first 5 years. So this p by factor considered for this, p by f factor considered for this, and then we simplify this by considering two interest rate, at 10% and at 12%, at 10% and at 12%, 10% and 12%, and that value comes as a 708 and the 12,000, not 708, 7,708, and second value comes as a 12,341. So for 10% I interest rate I, that value comes as a 7,708, and at 12% value interest rate I, that present worth value comes as a 12,341. Now with these two values, by interpolation formula we can find out this condition. So we have two values. So this is the present worth, this is the interest rate I. Interest rate we have two values, 10 and 12. Interest rate 10 and 12, and for this 10 interest rate some present worth value 7,708. For 12 interest rate this value comes as a 12,341, and at some intermediate I value, PW should be 0, and that is nothing but a internal rate of return. So we here we consider interpolation formula. Here we consider interpolation formula like this: 12,341 minus 7,708. Now divided this interest rate. So this is the present worth difference, and this is the interest rate difference. Now here this I value should be here. Towards this left side of this 10% interest, at which PW is equal to 0. So this I value represented here. So 10 minus I interest rate difference, and present worth difference is 7,708 minus 0. So it becomes as a 7,708. So solving this we will get I is equal to 6.67%. So this at this interest rate 6.67%, that Manish will get some amount. For particular investment of 12,000, particular investment of the 12,000. So this is the present worth case. By considering present worth method, we find out this internal rate of return.